And we're back again, Algebra 1, with our third installment of the properties of exponents, where we are still in Unit 4, Target 1, expanding and condensing expressions with exponents and learning about our properties of exponents. In Property 4, we're going to investigate the quotient of powers. So we're going to start by investigating, so we will fully expand x to the 8th over x to the 5th. So what does x to the 8th look like? Well, we have 8 x's on top divided by 5 copies of x on the bottom. So after we write our 5 x's, we are going to cancel any like bases in the numerator and denominator. So remember that when we're canceling, we cancel because we have like bases between the numerator and denominator. Whenever we have an x over an x, that will simplify to be 1. So those cancel, our second pair, third pair, fourth pair, and fifth pair. So after we've completely simplified, what are we left with? Well, we have 3 x's on the top, and since everything on the bottom simplified, we just have a 1 in the denominator. Or we can write this as x cubed. So when dividing like bases, how do we know how many bases and exponents are left over when we're dividing if we don't want to fully expand each time? Well, what we do is when dividing powers, we subtract the exponents. If you noticed in our investigation, the exponent of the numerator is 8 and the exponent of the denominator is 5. 8 minus 5 gave us our exponent of 3. So let's see what this looks like as a general case. If I have x to the a over x to the b, this becomes x to the a minus b. In this first example, we have a to the 10th over a to the 4th. So my common base is a, and I'm going to take the exponent of the numerator minus the exponent of the denominator. So a to the 10 minus 4. 10 minus 4 is 6, so we have a to the 6th. In example 2, the first thing I'm going to do is notice that we have a 3 over 9, which can be simplified. If I divide both 3 and 9 by 3, that simplifies to 1 over 3. Now I can worry about the d's as our bases that we need to simplify. So I have d to the exponent of the numerator, 7, minus exponent of the denominator, which is 3. So 1/3 d to the 7 minus 3 is 1d to the 4th over 3. In both of these examples, our variable has ended up on the same side where the majority of our bases began. So for example, in number 1, we had 10 a's on top. So that means that our a's will end up as a numerator. In the second example, we have 7 d's on top, which is more than 3 d's in the denominator. So that means that our d's, again, will end up as a numerator. Let's try the next example. So we have a cubed over a for our first set of bases. Now the a cubed on top, that's an easily visible exponent, but on the bottom I'm going to add in a 1 in the corner to show that that's the number that I'll actually be subtracting. So we have a to the 3 minus 1. Our second pair of like bases to subtract their exponents is x to the 4 minus 2. And the y's don't have a similar base on top to subtract with, so we're going to leave y squared on the bottom. We're just going to leave that right where it was. So a to the 3 minus 1 becomes a squared. X to the 4 minus 2 becomes x squared over y squared. And in our last example, again, we have 8 divided by 2. Both of those can be divided by 2 and simplify to 4 over 1. So we simplified our coefficient. Now let's move into our variables. So w cubed minus 1, because our w on the bottom has an exponent of 1. we have our k to the 7th minus k to the 1st, and d squared minus d to the 1st. So when we simplify this completely, we have 4w squared, k to the 6th times d. Now, since originally this denominator was just over 1, we don't necessarily need to write that in our answer. So we have 4w squared k to the 6th d. In our last property, we have the negative exponent property. So let's start by fully expanding. We have 4 x's on top divided by 9 copies of x on the bottom. X times x times x times x times 5 more x's. And now what we're going to do is cancel any like bases in the numerator and denominator, just like we did in property 4. So we have x over x simplifies 4 separate times for the x to the 4th on the top. So what are we left with here? Well, since we completely simplified the numerator, we're just left with a 1 in the numerator. What are we left with in the denominator? We have 5 copies of x in the denominator. Now let's try a different approach to this problem. Let's use our quotient of powers rule that we just learned to try and see if we can find a relationship between how we write our answer and our quotient of powers. So if I take x to the 4th over x to the 9th, and I use my quotient of powers, so I will take x to the 4 minus 9 over 1. X to the 4 minus 9 is x to the negative 5 over 1. Now, how does this answer match the one that we just came up with? Well, as it turns out, in this property here, when a base is raised to a negative power, we take the reciprocal of that base and the exponent becomes positive. So in this general example, if we have x to the negative a, then we take the reciprocal of x to the negative a over 1, which is 1 over x to the positive a. Or let's say that we start out with our negative exponent in the denominator. We do the same thing. We take the reciprocal and then the exponent becomes positive. In this first example, we have x to the negative 3rd power. So I'm going to start by giving this problem a denominator, a set numerator and denominator, so that I can easily tell what the reciprocal will be when I flip it. So the reciprocal of x to the negative 3 over 1 is 1 over x to the positive 3. Once your negative exponent flip-flops from numerator to denominator or denominator to numerator, the exponent then becomes positive. In number 2, the base that's being raised to the negative power is a. Notice that b is not being raised to a negative power, so b is going to stay put. So if a is what's being raised to the negative power, then that is what we're going to take the reciprocal of. So that means that a is now going to move to the top, and over 1 will be our denominator. So a moves to the top and becomes positive. So now I can just simplify this a little bit, write in alphabetical order. A to the 11th will go first times b, and I don't need to write over 1. In example 3, we only have one base that's being raised to the negative power. Only the b is being raised to the negative power, so that is the only base that's going to be moving. So our 5 will stay in the numerator, and our c to the 5th will stay in the denominator. The only thing that moves is what's being raised to the negative power. So if b started in the numerator, that flips to the denominator and then becomes positive. And in this last example, even though the 3 is multiplied by a negative 1, we're only looking for bases that are raised to a negative power, which have a negative exponent. In this case, only y is actually being raised to a negative power. So everything else will stay right where it is. So we have negative 3x squared on top, and my y to the 5th power will move to the bottom and become positive. Make sure that you try the problems on the right for both property 4 and property 5, and write down any questions that you have, and we'd be happy to go over those in class tomorrow. See you guys soon.